to Algebra with Miss Swartz. Today we are starting our new chapter talking about functions. Functions, probably a word that you may not have ever used before in math, but we are going to be spending the next few weeks going over functions, graphing functions, all types of different things with linear functions, function notation, standard form, slope-intercept form. So this gets into very much algebra topics for us. So we got to first figure out what functions are. So our goals today are to determine whether relations, which we'll talk about what that is, are functions. So we need to know how to identify functions. We're going to find the domain and a range of a function. So we got to talk about what the domain and range are. And then we're going to identify independent and dependent variables. So that kind of goes along a little bit with domain and range, but we'll discuss that as that comes. So we kind of have a lot to cover. So I want to try to move along quickly here. It's going to be a little bit of a longer video, so I'll try not to ramble. So, a relation. This in your journal, there is some room for definitions on page 61. So if you want to take your notes there, that's fine. If not, you can always do them in just your notebook as well. But a relation is pairs of inputs with outputs. So that could be a lot of different things. It's a very broad definition, and we'll look at what that looks like. But a function specifically is a relation that pairs each input with exactly one output. Okay? So each input has exactly one output. So there's some different ways that you can see a function, and we're going to be looking at a lot of the different ways today to be able to determine if they're a function. You could see it as an equation, okay, like y equals 5x plus 1, okay? So we have inputs and outputs. Your inputs might be x, your output might be y. You might see an input-output table. We will see those today. You might read it in words, not as common. You'll see some graphs. Graphing will be a big thing that we do. And then maybe a set of ordered pairs. Sorry, that's kind of cut off down at the bottom there. But a set of ordered pairs, so 1, 2, okay? These can be represented as functions if we have a set of them. So let's look at some examples of functions. Okay, so this actually is in your journal on page 59, so that you have it in front of you. But it says determine whether each relation represents a function and explain your reasoning. So if we look at A, okay, we have our inputs of x, and generally you will see inputs as your x variable. Okay, and we have these different options, 0, 1, 2, 3, and 4. So this is an example of an input-output table. Now, for the input of 0, we have 8 as our output. So for this input, we have exactly one output. Okay, for our input of 1, we have 8 as our output. We have exactly one output. Okay, for 2, we have exactly one output. So each input has exactly one output. So if we were determining if this was a function or not, yes, because each input has one output. Okay, so I would write that in your journal by it just so you kind of have an example. But this is a function because for every input, even though all the outputs are the same, it has exactly one output. Okay, meaning for each different input that I have, there's only one option for an output. Okay, so if we look at B, now we have the same input all the way across, and each input here has a different output. So does each input have exactly one output in this case? No, it does not. So it's not a function because the input value of 8 has more than one output. 8 has 0 as an output, 1 as an output, 2 as an output, 3 as an output, and 4 as an output. Okay, so let's continue looking at some other things. So here's another input-output table. It just looks a little different on C here. So 1 as an input has an output of 8, so that's good. It has exactly 1. 2 has an output of 9. 3, though, has an output of 10 and 11. So does 3 have exactly 1 output? No, so this would not be a function. 3 has more than 1 output. Okay, so let's look at our graph now. Remember, we can see it through a graph. So if we're looking at our inputs are always going to be our x values down here. Okay, so if we look at our inputs, we have 0 as an input. That would give us 8. 1, 6, 2, 4, 3, 2, 4, 2, 5, 4 and 5, 6, 5, 7, 5, but 7 also has 8, and 8, 8, 9, 9. Okay, so would this be a function? Because remember, each of these inputs has to have exactly 1 output. Well, in that case, not a function, because if we look at 5 and 7 have more than 1 output. So that's all you're looking for when you're determining whether a relation represents a function. See, we have some more options here. Okay, you can also look at them as ordered pairs. Okay, so remember, your x values are your inputs, your y values are your outputs. So I have to look, okay, -2, -1, 0, 1, and 2. So does each input have exactly 1 output? Yes, it does. So yes, this would be a function. Okay, so go ahead and look at F. Try that one on your own. Determine whether that's a function. Here's one of the ones that's like a word. G. Each radio frequency X in a listening area has exactly 1 radio station Y. So would that be a function? Well, yes, because each one has its own output. Okay, so try H. Then we can also look at these equations. So X equals 2. Okay, so in I, X equals 2. Well, the input value of 2 is paired with every possible output value of Y. So could this be a function? No, this would not be a function, because the input value here could be anything here for Y. So try J. Okay, so all of those are examples of what you may need to look at when determining whether something is a function, a relation is a function. Sorry about the drilling in the background. They are now taking off part of the crosswalk. Okay, so we have some more examples here. Input-output tables and order pairs. So if I look at this set of order pairs, I have -5 is 0, 0 is 0, 5 is 0, and 5 is 10. Well, this would obviously tell me right here, I have 2 inputs that have 2 different outputs, so no, not a function. So try 2 on your own. For this input-output table, I have 2, 4, 6. They all have exactly 1 output, so yes, this would be a function, because they all have different outputs. So you try 2 and 4. And you'll have some examples like this on your homework. So when we're looking at a graph, the nice thing is when we're trying to determine whether something is a function or a linear function, okay, we can check the vertical line test. It's pretty easy. If we're looking at a graph, all we have to be able to determine is that a graph represents a function when no vertical line passes through more than one point on the graph. So anywhere on the graph, if I can draw a vertical line through anywhere on the graph, then it would be a function. But like this one, okay, since here I would hit 2 spots on the graph, this would not be a function. So you can kind of determine functions that way. So if we look at this one, if I look at the vertical line test, would I be able to pass it? Well, in this case, no, because if I drew a vertical line here and here, it would go through 2 points. So this would not be a function. But if I look at this one, anywhere on the graph drawing a vertical line, okay, it is a function because I don't hit more than 1 spot on the graph. So you could look at all 4 of these. I won't do it on the video here just because it gets lengthy. But you could look at all 4 of these and determine whether these are functions or not based on the vertical line test. Okay, so the domain and range of a function. These are important terms. So these are also on page 61. You could write them in. Okay, the domain of a function is a set of all possible input values. Okay, what you can put in. So one good way to think about functions is kind of this like machine-like thing that they have showing here. You're going to put an input into the function. The function's, whatever the function is set up in here. So in this case, we have y equals 3x. We put the input in, which is our x, okay, which in this case we said is -2. And then our y is our output, what we get from performing that function. So once the machine has done its job, it spits out an output, which would be -6. That's our output. So the domain is all of the possible input values. The range is all of the possible output values. So let's look at a couple examples. So we can find the domain of some graphs very easily. The domain and range, all of our possible input values would be our domain. So any x value would be your domain. So look at your x values here. Okay, my x value here is -3. My x value here is -1. My x value here is 1. My x value here is 3. That is our domain. Any possible input value. Our output are our x values on our graph. Sorry, our y values on our graph. So if we look at our y values, okay, we'd have -2, 0, 2, and 4. Those are our outputs. So this would be our domain. This would be our range. Okay, so it's easy when they're just dots, but now if we have an something actually graphed, we have to look at that a little bit. So now we want to talk about where do they go from on the x and y axis. Okay, so in our domain, we want to talk about anywhere that it could be on the graph on this x axis. So the furthest or the smallest that it could be is at -2. Okay. And the biggest that it could be is at 3. So I can set up kind of an inequality here. So the smallest it could be, it's going to be, greater than, x is going to be greater than or equal to, because it's a closed circle there, and less than or equal to 3. Okay, so I'm going to rewrite that because it's kind of hard to see. Okay, so the smallest it can be is -2, so we want x to be bigger than -2 or equal to -2, and x to be smaller than or equal to 3. That's our domain. That's the x values. Now our range is the y values. Okay, so now we're looking at the y-axis. How far is the range from here to here? So the smallest it could be would be -1, so x is going to be greater than or equal to -1, but x is also going to be less than or equal to 2, because the highest it is at 2. So I want you to try these two. For this one, your domain is going to be your x values of those points. Your range is going to be your y values. For this one, you need to tell me, okay, how far along the y-axis, sorry, the x-axis your domain is, so from here to here, and then how tall your range is from here to here. So try those. All right, last part here. Independent variables and dependent variables. So independent variables are the variables that represent the input values of a function. They stand alone. They're independent of anything else. The dependent variables, this kind of makes sense if you think about it. It's dependent on whatever happens with the input here. So it's dependent on the independent variable. Okay, that's the output values of a function. So we just had this story problem that really represents independent and dependent variables. So it says the function y equals negative 3x plus 12 represents the amount y in fluid ounces of juice remaining in a bottle after you take x gulps. So it says identify the independent and dependent variables. So think about it. Which one does not rely on the other one? Okay, so the amount of gulps that you take is very independent of what's going to be left in the bottle, but what's left in the bottle is very dependent on how many gulps you take. So the gulps, x, is the independent variable. I can't spell. And y is the amount of fluid or juice left in the bottle, which is the dependent variable. Okay, so it says the domain is 0, 1, 2, 3, and 4. Remember, your domain is all of your input options. Okay, so 0, 1, 2, 3, and 4. Those are all of your input options, your independent variable options. Okay, it tells us the function y is equal to negative 3. Where did my pen go? Plus 12. So I can plug in my independent variable to get my dependent variable. So if I did that, this would be 0 plus 12, so my dependent would be 12. Okay, same thing here. If I plugged in 1, I would get negative 3 plus 12, which would be 9. If I plugged in 2, I would get negative 6 plus 12, which would be 6. If I plugged in 3, I would get negative 9 plus 12, which would be 3. 4, I would get negative 12, which would be 0. Okay, so these would be my range. Okay, if you have specific questions on that, please do ask because you have a problem like that on your homework. All right, we're going to call it a day because this video is very lengthy. Your homework is on page 63 in your journal. Have a great day.